It is 9:12 on Monday. Your high-severity login rules stopped firing over the weekend. The analyst on shift swears nothing changed. The engineer says they only cleaned up a condition. The console shows the current rule, not the useful history. No clean diff, no review trail, no tested rollback. Now the SOC is rebuilding logic from memory, while leadership asks why coverage disappeared. That is the pain point. SIEM detection rules version control turns that mess into a normal engineering workflow. SIEM detection rules version control means your detection logic lives as plain text in a Git repository, instead of only inside a point-and-click console. A rule might be YAML, JSON, TOML, SQL-like text, or another readable format. The exact syntax matters less than the practice. Every rule has a file. Every change creates a diff. Every proposed update goes through a pull request. Every approved change has a commit with an author, time, and reason. In NIST style terms, this is configuration management and change control for detection content. A beginner can say it this way. Rules as code means we manage SIEM detections like controlled source files, not mystery settings. Life before rules as code is messy. Someone opens the SIEM console, edits a detection, clicks save, and moves on. Maybe the console logs the editor name, maybe it does not. Maybe it shows a previous version, maybe it only shows the final state. The real problem is that console-only rules are unauditable by design. They hide the exact logic change that matters during an incident review. Did the time window change from 10 minutes to 1 hour? Did an exception swallow a whole business unit? Did a field name get renamed? Without a diff, review becomes opinion. Without history, accountability becomes memory. Without rollback, recovery becomes manual reconstruction. The mechanics are simple. First, choose a rule and represent it as text. Include the query, severity, schedule, required fields, test notes, and owner. Second, commit that file to a Git repo with a clear message. Third, any future change starts in a branch. The analyst edits the text file and opens a pull request. The pull request shows the exact lines added, removed, or changed. Fourth, another defender reviews the logic before deployment. They look for broken field names, dangerous broad exclusions, bad thresholds, and missing context. Fifth, after approval, a controlled process pushes the rule into the SIEM. If the change breaks production, rollback is a Git revert, not a memory exercise. Here is a real SOC pattern. A team has a rule for impossible travel. It fires too often for a remote support group. An analyst wants to add an exception. In the old model, they would edit the rule in the console and hope the noise drops. In the rules as code model, they change the rule file and open a pull request. The diff shows one new exclusion. The reviewer notices the condition excludes the entire support department, not just the managed jump service. That would remove useful coverage. The analyst narrows the exception, adds a comment explaining the business reason, and links the ticket. The rule deploys cleanly. 2 weeks later, if it misbehaves, the team can revert the exact commit. The strength is control. You get a clean audit trail, repeatable review, and a rollback path. Commit history answers who changed this, when, and why. Pull requests make detection engineering visible to the team. Diffs catch small mistakes that cause big gaps. But version control does not prove a rule is good. It does not guarantee the data exists, the logic is accurate, or the alert is useful. You still need test events, sample logs, field validation, and production monitoring. It also adds workflow. People must write clear commit messages, review with care, and avoid emergency console edits becoming the normal path. The repo improves accountability. It does not replace judgment. Rules as code sits inside detection engineering. It supports the SIEM, but it also connects to the wider defensive stack. Tickets explain why a rule changed. Case management shows alert outcomes. Log pipelines confirm the fields still arrive. Automation can deploy approved rules or run lint checks before release. UEBA teams benefit too. If a behavior model has thresholds, allow lists, or suppression logic, those settings meet the same traceability. The goal is not to turn every analyst into a software engineer. The goal is to stop treating detection logic like loose notes inside a console. The SIEM remains the alerting engine. Git becomes the system of record for detection intent. Start small. Pick one important rule, preferably one that has caused noise or outages before. Export the logic or rewrite it into a plain text file. Add metadata at the top: owner, purpose, severity, log sources, expected fields, schedule, and a short test plan. Commit the first version. Then make one safe improvement through a pull request. Ask another analyst to review only the diff. Keep the review focused. Does the logic still match the detection goal? And could this suppress more than intended? After deployment, document the result. Then practice a revert in a non-production path, so the team knows the motion. The first win is one rule, one repo, one rollback path. Recap in 3 beats. First, store SIEM rules as plain text in Git, not only as console settings. Second, make every change a pull request so the team can review the diff before production. Third, use commit history and git revert so you know who changed what, why it changed, and how to get back fast. Console-only rules leave too much to memory. Rules as code gives the SOC a record, a review gate, and a recovery path. If this helped, subscribe to the channel. A new Security Tools Decoded episode drops daily, and we also publish the daily ranked CVE brief for defenders who need the signal without the noise.